Hi, my name is Sherla son of Armugam. My matrix number is 14DKM20F1061. I am representing the class DKM2A session 2. Today I am going to apply the technique of integration area under a cover.
Okay, let's say that we had a function fx equals to x square, which we can draw on a grid. And let's say we are interested in finding the area under this curve from, say, x equals to 0 to x equals to 1. We can apply the fundamental theorem of calculus, which tells us that if we integrate our functions x equals square with respect to x from 0 to 1, then this will equal to the area under the curve. This tells us, applying the fundamental theorem of calculus, that we need to find an antiderivative of fx at 1 and subtract from that the antiderivative of fx at 0. So how we find the antiderivative? Let's go over to this side here and just review a couple of concepts: derivative and antiderivative. The derivative and the antiderivative can be thought of as opposites of each other. So let's say we have function fx equals to x square. We know that if we are going to find a derivative of this function, it would equal to x. The power rule tells us to take the exponent, multiply it by what is front, and the subtract on 1 from the exponent. So if we had the same function fx equals to x square and wanted to find an antiderivative of this function, we do the exact opposite. We would add 1 to the exponent first, then divide by this value, and this would leave us then with x cubed divided by 3, which becomes the antiderivative of x square. We end up with a progression. So you have the function x square and its derivative becomes 2x, and then its antiderivative becomes x cubed over 3. Such that the derivative of the capital F function is the small f function, and the derivative of small f function is f prime function. Okay, let's come back now and finish off our problem. We know that the antiderivative of x square is x cubed over 3, and what we want to do here is then substitute the value of 1 in for the antiderivative, and then we want to do same thing for at 0, and what we end up with is 1 cube, which is 1 divided by 3, which is equals to 1/3 minus 0. So the area under curve of x square from 0 to 1 is 1/3, whatever the units may be.
A very good morning to my lecturer and my fellow friends. I am Lingeshwara Nallaki Selvaraju from class DKM 2AS1. My metric card number 14 DKM 20F1029. Okay, today I am going to explain this question. Find the volume of generated when the shaded region is rotated through 360 about the x-axis. Okay, this is the shaded region, and now we are going to find the volume generated. Okay, pi 2 to 0 y square equals to dx. Okay, here is 2. I put 2 because x equals to 2, and here is 0 because 0 to 2, and y I just simplify this one and I get y square dx. Okay, now pi 2 to 0 x square equals to x square bracket x plus 1 close the bracket 2 dx. Okay, now we must expand this equation, then we get this, and then we must integrated this equation. Once we integrated, we get this. Then for the last step, we must convert the x to 2, these two. So this 2 and 0, we must convert this x. So once we convert, we get this, but then 0 is nothing, there is no value for 0, so we put the 0 at here and minus with the equation. So the final answer we get 256 over 15 pi. Thank you.